Here the topic is twin primes. In the list of primes, it is sometimes true that consecutive odd numbers are both prime. We have boxed these twin primes in the following list of primes less than 100. Actually, twin primes we have already discussed, and at introductory level, the twin primes is a set of primes with the difference of 2, like 3 and 5 are twin primes, same 11 and 13, 17 19, 5 7, 29 31, 41 43, 51 59, 61, 71 73, and so on. There are infinitely many twin primes, that is, there are infinitely many prime numbers p such that p plus 2 is also a prime. At present, no one knows the answer of this question because the search of prime numbers is still going on, and this is the very diversified field of the mathematics. So here you can see 3 5 7 are in the list. Same here, 11 13, 17 19, 29 31, 41 43, 59 61, 71 73. There are infinitely many twin primes, that is, there are infinitely many prime numbers p such that p plus 2 is also a prime. At present, we can see we have some list of the twin primes. Same primes of the form n square plus 1. If we list the numbers of the form n square plus 1 taking n equals 1 2 3 and so on, we find that some of them are prime. Of course, if n is only interesting to take even values of n, we have highlighted the primes in the following list, like 2 square plus 1 equals 5, 4 square plus 1 equal to 17, 6 square plus 1 is equal to 37, 8 square plus 1 equal to 65, 5 into 13 is in the form of 65. Same 10 square plus 1 is equal to 101, 12 square plus 1 is equal to 145, 14 square plus 1 is equal to 197, 16 square plus 1 is equal to 257, 18 square plus 1 is equal to 325, and 20 square plus 1 is equal to 401. It looks like there are quite a few prime values, but if you take larger values of n, you will find that they become much rarer. So we ask whether there are infinitely many primes of the form n square plus 1. Again, no one presently knows the answer to this question because we have infinitely many prime numbers, and in this format we have to search the numbers continuously. We have now seen some of the types of questions that are studied in the theory of numbers. How does the attempt to answer this question, and what are the strategies, how we can implement the concept for finding the result or proving the question. So the experimental part normally comes first. It lists two questions and suggests ways to answer them. The theoretical part follows. In this part, one tries to devise an argument that gives a conclusive answer to the question. In summary, there are the steps of follow. First, accumulated data, usually numerical but sometimes more abstract in nature. Secondly, examine the data and try to find patterns and relationships. The third is formulate conjectures, that is guesses that explain the pattern and relationships. These are frequently given the formula.